So before we start looking at our algebraic division, we need to make sure that we understand the difference between proper rational functions and improper rational functions. So a proper rational function could include something like x plus 1 over x squared plus 2. Could be something like x cubed minus 7x squared plus 5 over x to the 5 plus 17x squared. It could be x to the 4 plus x cubed minus x squared all over x to the 5 minus 13x. Okay, whatever, it doesn't really matter. In order for it to be a proper rational function, the degree, okay, we were talking about the degree, we just mean the power of the numerator needs to be less than the degree of the denominator. Okay, and so it's not just any old thing, it is the highest power that we're looking at. So we're looking at the thing with the highest power on the top, the thing with the highest power on the bottom, and so for this to be a proper rational function, the largest power needs to be on the bottom of our fraction. Okay, on the other hand, if we were to think about some improper rational functions, we might have something like x cubed over x squared plus 1. We could have x to the 5 plus 17x squared all over x cubed minus 7x squared plus 5, x squared plus x minus 5 over x to the 7 minus 2x plus 6. Again, it doesn't really matter. Okay, what we're looking at in these cases though is that the degree of the numerator, so the highest power in the numerator, needs to be bigger than or equal to the degree of the denominator. Okay, so that is what we are talking about here. If we find ourselves with an improper rational function, then they can be simplified using our division. So improper rational functions can be simplified using algebraic division. So let's take, for example, x cubed plus 4x squared minus x plus 2, and we want to divide that by x squared plus x. So set it up like we would do any other long division sum. So we've got x squared plus x. Let's see how many times that goes into x cubed plus 4x squared minus x plus 2. Okay, so we're always going to be thinking in this part here, in this first part on the left, how do I get this term to match the next highest to be divided? So highest thing to be divided here is the x cubed. How do I make x squared look like x cubed? Well, I'll multiply it by x. And so I'm going to multiply this whole thing here by x. And so I'm going to get x cubed plus x squared. And I'm going to subtract that. So I've got x cubed minus x cubed is 0. 4x squared minus x squared leaves me with 3x squared. And I'm going to carry down this x bit to help me. So what we're thinking about here is, how do I get this term, and we're thinking about that one there, to match the next thing to be divided. Okay, so really what we should have said is the next highest thing to be divided. Okay, so this is what we're thinking about. It's always the highest power in this thing here. So how do I make this x squared look like the 3x squared that's left here? It's the highest thing I need to have. Well, I multiply it by 3. So I'm remembering that, and I've got 3x squared plus 3x. And I'm going to subtract that. Minus x minus 3x gets me to minus 4x. And I'll bring down my plus 2. Okay, so just remind ourselves of our steps. What we've done, some squarey brackets here, is we did x squared plus x, and we multiplied that by x. And then here, I took my x squared plus x, and I multiplied it by 3. Okay, that's how I got each of those lines. Once I get to this bit though, I can't make it match anymore. Alright, the highest power of the thing still to be divided is no less than the thing I'm dividing it by. And so what that is going to mean is that my fraction of x cubed plus 4x squared minus x plus 2 all divided by x squared plus x can be divided to give me x plus 3 times, and a remainder here of minus 4x plus 2 that has not yet been divided. And so it gets written like that as my wee fraction. Okay, let's try another one. That was the first time we've seen this, so second, let's do x to the 5 plus 1 over x cubed minus x plus 1. So x cubed minus x plus 1. Now we want to divide this into x to the 5. Now, just like our synthetic division that we have seen before, we've seen it higher, we've got to include every power less than it, whether it's there or not. Okay, so this is what I've got to do. So I'm looking at the highest power here, and I'm trying to get it to that one. Well, how do I get it matched? Well, I'm going to multiply it by x squared. So I get x to the 5, I've got no x to the 4th, I'm going to have a minus x cubed, I'm going to have an x squared. And so again, just as a wee reminder of what am I doing here? Well, I'm doing x cubed minus x plus 1, and I'm multiplying that by x squared. And I'm going to subtract. So that bit goes away. X to the 5 minus x to the 5. I've got no x to the 4s, take away no x to the 4s. No x cubed minus x cubed gives me 1x cubed left. Okay, no x squareds minus an x squared is minus x squared. And then I can carry these bits down. So I've still got plus no x, I've still got plus 1. So how do I make this bit match? How do I make x cubed match x cubed? Well, it's actually already there, so it's just 1 and multiply it by. So x cubed, and I've got no x squareds minus x plus 1. So x cubed minus x cubed is 0, minus x squared minus nothing is still just minus x squared. I've got no x's and I try and take x away, so I'm trying to subtract minus x, so I'm at plus x, and I've got 1 minus 1, well that just leaves me with 0. And so what I can say then is that x to the 5 plus 1 over x cubed minus x plus 1 is equal to x squared plus 1, and then I was left with minus x squared plus x all over x cubed minus x plus 1. Now this, our algebraic division here, is quite often the first step before you then have to find partial fractions. So a lot of the time we'll ask you to find partial fractions of something like this. Okay, we may or may not kind of preempt you that you need to do the division first. So you need to be keeping an eye out that when the degree in the top is bigger than or equal to the degree in the bottom, that you need to do your division. Okay.